Welcome back to Easily Explained, where today we will be talking about direct variation. So let's get started. So when we talk about two values that vary directly, those two values are directly proportional. So what do we mean when we're saying directly proportional? When two values are directly proportional, if x is increasing, then y is also increasing. But if x is decreasing, y is also decreasing. There is also a constant rate of change. So what I mean by this is when, for example, if x is increasing by 1, if we're just going 1, x is equal to 1 to x is equal to 2, y is increasing by 10, for example. So each time that x increases by 1, y increases by 10. And that y increasing, our slope, our constant rate of change, is going to be very important for this next step, which is the equation that direct variation is defined as. So the equation is y is equal to kx, where k is not equal to 0, and k is the constant of variation. The constant of variation and constant rate of change, they are all the same. Now we are going to be using direct variation to solve some problems. For instance, we are given a situation, we are told that the amount of miles driven, we're calling that the variable y, varies directly as the number of hours driven, which is x. In 7 hours, the driver has drove 280 miles. Now we can use direct variation to find k. If we go back, k is the constant of variation, or the constant rate of change. So there are a couple different ways we can approach this problem. But first, we want to realize that since it represents direct variation, we know that the amount of miles increases as the number of hours increase. So there are different ways that we can approach this problem. The first way is by using a proportion. So let's set up a proportion. We know that 280 miles were driven in 7 hours, which is equal to, because it's a constant rate of change, that means it's going to be equal to k amount of miles, k. That's what we're trying to figure out, is how many miles is it increasing by, or how many miles are driven in 1 hour, because in this case that's going to be our slope or constant of variation, and this is all in 1 hour. Now we can cross multiply to solve the proportion and say 280 times 1 is just 280 is equal to 7k. Remember, there's no way to simplify 7k until we know the value of k, which we're going to do by isolating the variable. How do we isolate the variable? Well, we always want to do the opposite operation, and in this case 7k means 7 times k. That's multiplication. So the opposite of multiplication is division, so we're going to divide both sides by 7. 280 divided by 7 is 40, so k equals 40. So in 1 hour, the driver had driven 40 miles. And since it's constant, every single hour he drove 40 miles. All right, now let's look at the second way that we can solve this. The second way is by plugging all of our values into y is equal to kx. We know that one value of y is 280, and then we have k, and we have a value of x, 7. Now we also are left with the exact same thing. Since it's still being multiplied, we're going to divide either side by 7, and we're going to get 40 is equal to k. So in either cases, k is equal to 40. Now we are going to write the direct variation equation. So now, basically, when we looked at the equation y is equal to kx, k is not equal to 0, and k is the only real value that we actually have to plug in an actual number and not leave the variable. And since we just found that k is equal to 40, our equation is just y is equal to 40x, because y is equal to kx and k is equal to 40. We aren't plugging in y or x because that is for you to plug in when you're given a specific value of x or y, then you can solve for the other one. So now let's do that. You're given 4 hours and you want to solve for how many miles are going to be driven by that time. So this and that, we are solving for y while we're given x. So we can just plug in our x value. So 160 miles is your answer. He's going to drive 160 miles in 4 hours. And now it's time for your practice. So for the situation below, you're going to A, find k, B, write the direct variation equation, and C, solve for the height of a stack of 200 books. So pause the video now and get started on the practice problem. So the height y of a stack of books varies directly with the number of books, x. So that means that as the number of books are increasing in the stack, the height is also increasing. We're also given that when 10 books are stacked, the height is 15 centimeters. So now to find k, we're going to plug that into the direct variation equation. Y is equal to kx. So our y in this case is 15 and our x is 10. So we're going to isolate the variable by dividing both sides by 10, and then we get k is equal to 1.5. So the constant rate of change is 1.5 centimeters. We could also use a proportion to solve this from the very beginning. B, write the direct variation equation. Now that we have found k, all we need to do is plug in k, and there's our direct variation equation. And lastly, we're just going to plug in x as 200 to find the height, y, 1.5 times 200. And we get y is equal to 300 centimeters. Congratulations, you are now an expert at direct variation. If this video helped, please like, subscribe, and share with your friends. And we'll see you guys next time. Bye!